Hey everybody, Ryan here. Welcome to this video that I've prepared on basic dental instruments. Whether you're joining the dental workforce, maybe you're interested in pursuing dentistry as a possible career, or maybe you're a patient and just want to learn more about the field. Well, this video is designed to give you a basic understanding of different dental instruments and what they are used for. So sit back and relax as we dive into the world of dentistry. So the two main categories of dental hand instruments are non-cutting and cutting instruments. This is by no means a comprehensive list, but I've included the instruments that are most frequently used by myself and what you might find in a typical cassette for routine exams and operative procedures. Some of them might sound scarier than others, but let's go through each one at a time to help you get a better understanding of common dental instruments. Near the end of the video, we can talk briefly about handpieces, which fall into their own category. So dental hand instruments have three main regions, and they're important to keep in mind as we talk through each instrument. So the part labeled C is referring to the handle of the instrument. It's about 6 millimeters in diameter. It's either 8-sided or round. It sometimes has a ribbed grip like you see here for better handling, or it can be smooth and flat. The B section refers to the shank, which may or may not have one or more bends in it so that the blade of the instrument is aligned with the long axis of the handle. And I already talked about this. The shank transitions into the working end, which should lie in the long axis of the instrument for best balance and control. So the working end, which is labeled A in this diagram, consists of either a blade and a cutting edge for a cutting instrument, or a nib and a face for a non-cutting instrument. And because this diagram is showing a cutting instrument, the whole A section would be the blade of the working end, and the actual sharp functional cutting part would be the cutting edge of that blade. So here is another schematic showing the parts and pieces of non-cutting and cutting instruments. So enough about that. Let's go into specific hand instruments, and we'll start with the non-cutting variety. All right, so first we have the dental mirror. And you may be wondering, why do we even need a mirror like this? Well, some tooth surfaces are really difficult or even impossible to see without it. For example, the biting surfaces of upper teeth would require you as the operator to have the patient sitting way back and you craning your neck way up and to the side just to get a decent look. The cheek surfaces of the molar teeth would require you to stretch the cheeks really far to get just a decent look at them, but the mirror makes all of this a lot easier. We call this ability to look at oral structures using the mirror indirect vision. And you can try indirect vision yourself if you have a wall mirror in your bedroom or your bathroom and a separate hand mirror. You stand with your back to the wall mirror and then hold the hand mirror in front of you, and then try to look at the back of your head, angling and using both mirrors. It can be a little disorienting to track your movements, like if you were brushing your hair in this fashion, for instance, but this is the learned skill of using indirect vision. And really all it takes is some practice. Another really cool thing I did back in dental school to practice was buy a cheap plastic dental mirror, take a piece of paper, and then while looking only into the mirror, try to write my name upside down on the paper. So it looks right side up in the mirror, but your hand has to do just the opposite. So it's a fun little trick you can do at home, and I found it really helpful for just getting indirect vision to start clicking. All right, next we have the Explorer. The Explorer provides tactile sensitivity to detect if edges of fillings have good integrity with the surrounding tooth structure. Also, margins of crowns fitting well to the tooth, and other purposes like that. Historically, they've been used to probe and poke tooth structure to detect cavities, but doing so too roughly can actually induce a cavitation into weakened enamel, so they should be used gently if used in this way. So here we have the shepherd's hook. It's the classic curved end of the Explorer. It's also noted number 23 Explorer. Number 17 Explorer is the flatter, shorter hook on the other end of this one, which is great for interproximal areas between the teeth. And lastly, there is the 3CH Explorer, also called a cowhorn or a pigtail Explorer, which curves under and around the teeth and can be preferred by some providers for detecting crown margins and other things that might wrap around and underneath the bottom of the tooth. Next, we have the periodontal probe, and this is used to measure the pocket depth between gum and tooth to detect the presence of gum disease. Of course, they can also be used to measure other things like width of teeth, amount of overbite, and things like that. So we have a couple different measuring designations depending on the type of probe that you use. Up here is the UNC 15 probe, and on the top you can see here that each mark represents 1 millimeter, and then the first thicker line goes from 4 to 5 millimeters. Then we have 6, 7, 8, 9, and 10 are the next two of the darker, thicker black line, and then so on. The next one here is called the Williams probe from the University of Michigan, and this one goes again in 1 millimeter increments, but it leaves out or omits 4 and 6 millimeters. So otherwise it includes 1 to 10. And lastly, we have the Marquise probe, which has 3 millimeter increments and the blocks of lines and alternating no marks, marks, no marks, marks. That's 0 to 3, then to 6, 9, 12, 15, and so on. So those are just 3 of several different configurations for periodontal probes used to measure. Next, for non-cutting, we have the amalgam condenser, which is used to squish amalgam material into the depths of a cavity preparation so that's properly condensed. Some dentists can actually or prefer to smush amalgam into a cavity prep with their gloved finger, but to really get it properly pushed into the corners and the edges of a cavity preparation, you need an instrument like this. It can also be used for condensing composite material into the base of a prep in a similar fashion. So the nib of this device, this instrument, is the portion of the condensing instrument that comes into contact with the restorative material being condensed. And the very end of the nib is called the face, and it's usually smoothed but can be serrated. And lastly, for non-cutting, we have the ball burnisher. Now this one's one of my personal favorites. It can be used for burnishing or even carving the surface of an amalgam filling before it completely sets to give it some contour and anatomy. It can also be used in a similar way to smooth out the occlusal surface of a composite restoration before it is cured. And you can see it usually has some different ends on it. This one has 2 spherical ends, one bigger than the other, and others have 1 spherical end and then 1 more football-shaped end. All right, so that was a little bit on non-cutting instruments. Now let's talk about some cutting instruments. This is a little bit of an overgeneralization, but this is generally what each of these categories of instruments applies to and works on. The scalers working on calculus, excavators being used on dentin, chisels being used on enamel, and then my other miscellaneous category being used to modify and edit restorative material. So keep this in mind as we go through the next few instruments. So in addition to the 3 sections of an instrument, we can now introduce a formula that describes the dimensions of the working end of most cutting instruments. Now, I won't belabor this point too much, but it is interesting to know that there is a 3 or 4 number formula that can describe most cutting instruments. The first number refers to the width of the blade. So in this example, this instrument has a first number of 10, so that refers to this dimension of the blade being just 1 millimeter. So this number is referring to the width of the blade in tenths of a millimeter. The second number refers to the angle of the cutting edge relative to the long axis of the blade. So in this scenario, the blade's long axis is like this, and the cutting edge is like this. So they form a 90-degree angle, and the cutting edge is perpendicular to the blade. So it's omitted if that's the case. It would be 90 degrees, but we actually don't include that number. The third number of the formula refers to the blade length. That's simply the length of the blade right there. And because the number is 7, this is measured in millimeters, so the blade is 7 millimeters long. And the fourth and final number of the formula is probably the most complicated. It refers to the angle of the blade, this time, relative to the long axis of the handle. So this is the handle here. I already basically drew the long axis of the blade, so the handle would go something like this if we were to continue that long axis. And the number doesn't refer to the actual angle this time, like the second number. It refers to the percent of 360 degrees. So 14 would mean 14% of 360 degrees, which is about 50 degrees. So this angle right here that the blade takes relative to the handle is about 50 degrees. So if you know the 3 or 4 numbers of a formula, you can visualize and even identify what kind of hand instrument it's describing. In this case, 10714 refers to an enamel hatchet, which we'll talk about in just a little bit. All right, so our first cutting instrument we'll talk about is the scaler. Now, scalers are usually two-sided instruments, each with its own working end, and each working end has two cutting edges that adapt closely to the tooth and remove calculus from the crown or root surface. There are universal types that can be used anywhere in the mouth, and then specific types like Gracie's that are designed for specific teeth and specific areas in the mouth. Sickle scalers with sharp points are used for calculus above the gum line, and curettes with rounded ends are used for calculus below the gum line. That's because it's a little bit more gentle when used below the gums. I have much more in-depth information about hand scalers in my periodontic series, so go check that out if you're interested. The spoon excavator, with a formula of 11.5714 as an example, is used for gentle and controlled caries removal. So some operators prefer to use a round burr and a slow-speed handpiece. We'll talk about that a little bit more later. And others like to use small controlled movements with the spoon excavator to scrape carious dentin with the paddles of the spoon excavator. There's also the black spoon, which is a larger, more robust version of the spoon excavator I just showed you. And this one has some other uses. It can also be used to burnish metal, like a matrix band or the margin of a gold crown, with the rounded end or the back side of the spoon. Next we have the enamel hatchet. This is a double-ended cutting instrument used for planing walls of enamel. This is the one we were looking at before with the formula 10714. The bevel on one end planes the facial wall, the bevel on the other end planes the lingual wall, and vice versa if you're in another part of the mouth. Here is an example of an enamel hatchet used to plane unsupported enamel from the facial wall of a prep. Next, we have the bin angle chisel. This is also a double-ended cutting instrument used for planing walls of enamel, and it's called bin angle because there are two angles in the shank of the instrument. So if this is the handle, we transition to the shank. There's one more subtle angle, and there is the second. And you can also see it in this diagram here and here. And then we transition into the working end. So this angling of the shank is to allow for proper orientation of the blade and to provide balance when using the instrument. It's similar to the enamel hatchet in function. Both are used to plane walls of enamel, but the blade is perpendicular to the blade of the enamel hatchet. So you can see the difference. This one is flat to the screen, and this one is facing the other way. So this enables us to use this instrument in another part of the mouth where the enamel hatchet couldn't access. And next we have the gingival margin trimmer. Again, similar to the last two, except this instrument is designed for planing enamel at the gingival floor of a prep rather than the facial and lingual walls. The cutting edge is most importantly not perpendicular to the blade of this instrument. So there's a second number in the formula to represent that. If that number is less than 90 degrees, then it's used for the mesial side of the tooth. If it's greater than 90 degrees, it's used for the distal side of the tooth. So this represents a mesial marginal trimmer, this a distal marginal trimmer. And so instead of being used for facial and lingual walls, the margin trimmer is used to plane or trim off this unsupported enamel at the gingival floor. All right, next we're moving into our other category. The discoid cleoid is a double-ended, round-handled instrument used for carving and contouring amalgam. So the cleoid end is this claw-like end used for carving grooves into the amalgam. The discoid, or circular disc-like end, is used for carving pits and fossa into the amalgam. The Hollenbach carver is also a double-ended round-handle instrument used for placing, carving, and contouring amalgam. The two ends are oriented 90 degrees to one another. All right, so now we can talk a little bit about how we hold all of these dental instruments that I just talked about. So a normal pen grasp involves directly holding a dental instrument with your index finger and thumb, so the instrument rests on your middle finger. And you can try this with a pencil or a pen or whatever you might have at your disposal. With this grasp, your ring finger is used as a finger rest. And then we have the modified pen grasp, which is my personal favorite and what's taught in many dental schools. And this is where you add the middle finger to grabbing the instrument directly. And so the instrument then rests on your ring finger, which provides additional control. Now having 3 fingers instead of just 2, it provides additional control for fine motor function. And then you can use your ring finger and your pinky finger together as a finger rest. And what do I mean by finger rest? Well, all grasps require firm finger rests, which provides a fulcrum point so that your hand is stable, and in case the patient moves, you move with them because your instrument is in your hand and then your hand is resting on some stable structure. So best to use is adjacent teeth and the maxilla. And those are the most stable landmarks. The mandible is stable if the patient is biting on a bite block, but otherwise, they can just open and close at will, so it's not always the best finger rest. Also, use a short working radius. Don't overextend the instrument, and don't hold the instrument too far back. So this means you should grab the instrument more towards the working end, so your fulcrum is nearer to the working end for more control and more accuracy. All right, now we can talk about rotary instruments. So this is the handpiece category. So low speed or slow speed handpieces operate at less than 12,000 RPM. RPM stands for revolutions per minute. And even though it's the slowest, 12,000 RPM is still fairly fast. That's 200 spins per second. And so it can easily injure yourself or your patient if you're not being careful while using the instrument. Low-speed handpieces are used for cleaning teeth with a prophy cup and prophy paste, caries excavation, like we talked about before, as an alternate to using the spoon excavator, and finishing and polishing a restoration with a polishing cup or a polishing brush. Here is the slow-speed motor. This is the latch-type contra-angle attachment, referring to the fact that it angles away from where you're working, contra angle. And this is the straight attachment, and that's used for the prophy cup for hygiene cleanings. The high-speed handpiece is used for tooth preparation, for fillings, crowns, removing old restorations, and many other procedures that require quote-unquote drilling teeth. And they operate at over 200,000 RPM. They usually have and this is a high-speed handpiece, they usually have a fiber optic light. They usually operate with air-water spray and so on. So the medium-speed handpiece is between these two, and it can be like an electric handpiece where you can actually control the mean RPM of the instrument. So medium speed can be used for the same applications as high speed, but depending on the RPM you have it set at, it may not be quite as efficient. The rheostat is the foot pedal that is used to control all of these kinds of handpieces, often with variable speed depending on how hard you push down with your foot. And the little switch here turns the water on and off if you're using a handpiece with air-water spray. So that's the handpiece. Now let's talk about the burrs that go into the handpieces. So the burr has its own anatomy, and it consists of the shank, which is the actual part that's inserted into the head of the handpiece, the neck, which transitions to the head, which is the actual cutting part of the instrument. So number 1 refers to a high-speed burr, and number 2 refers to a latch-type slow-speed burr that would fit into the contra-angle latch-type attachment I showed you here. And so this high-speed burr would fit into this handpiece here. So there are different types of materials that burrs are made of. Now, diamond burrs were historically called diamond instruments and not burrs, but we can collapse them into the greater category of burrs, as the ADA and dental product companies have already done for us. So carbide burrs are made of tungsten carbide, and this is what they basically look like. They come in many, many different sizes and shapes. Because of their material and their design, they're better for end cutting, like with punch cuts to start a preparation. They also create a smooth preparation wall. They're good for amalgam removal and creating retentive features, and produce lower heat than their counterparts. Diamond burrs are better at side cutting and are therefore preferable for most preparations, especially crown preparations, bevels, enameloplasty, and this is due to the greater hardness of diamond and overall more effective cutting. But as a downside, it generates more heat, and they're also way more expensive. So the finer grit of the diamond, the less aggressive the burr will be. And for carbides, the more blades that a carbide burr has, the less aggressive that burr will be. So the more you would use it for finishing and polishing rather than cutting and drilling tooth structure. Alright, so that's it for this video. Thank you so much for watching, everyone. If you're interested in supporting the channel, please check out my Patreon page. A huge thank you to Michael Raja, Eins Lau, David Jaden, Yanet, and all of my patrons for all their support. You can unlock extras like access to my video slides to take notes on, and practice questions, so go check that out if you're interested. The link will be in the description. Thanks again for watching, everyone. I'll see you all in the next video.